All right, welcome everyone to the 15th ROS2 Hardware Acceleration Working Group meeting. Today we have a bunch of topics we'll be covering, so let's get into it. As always, I'll be sharing first the minutes in the chat. So let me push it right in here for all of you, and then let me share my screen. Okay. So again, 15th meeting of the working group. To get started, I wanted to share a couple of updates with everyone. The first one is that the working group is growing, actually significantly. We are increasing also the periodicity of calls. Previously, if you remember, we were meeting once a month, and we will continue doing so. Typically, at the end of each month, we will have each meetings. But now, with the advent and increase, as well as increase of popularity of some of these sub-projects of the working group, we are moving also to weekly meetings, especially for the RobotPerf sub-project. So very happy to share it with everyone. Last week, we had the first RobotPerf weekly meeting with a pretty decent attendance for being the first one. The recording and material, as always, is available. You can check it out. It's in this same resource. So we're going to be reusing the same resources of the working group just to make sure we leverage and make everything usable and accessible. So again, the resources are in here. Check it out. So that's one first bit of excitement. The second one is that we are holding also today, as part of this meeting, concurrently, the first meeting of the Architectures and Processors Working Group of the Spanish Association in Semiconductor Industry. We're doing lots of stuff that relates to essentially building up and bringing both as soft cores and hard cores. So we thought it was going to be a good opportunity to bring ISME folks, which we are part of, within the Spanish domain into this international community we've been leading now for quite a few months, I would say, actually more than a year now, so that they can take part of it, contribute, collaborate, and maybe also bring their 2 cents. That's about it. With this, I'd like to welcome everyone to the meeting. If you're new to the working group, you can check out the attendance in the LinkedIn event. We will not be recording every single participant because there's already more than 30 persons that joined today. So to save my time and the time of my people helping me admin this working group, you can just refer to the LinkedIn event, and that's going to be faster. Let's start with the progress review on various of the projects. The first one I'd like to start with is the Robotics MCU, or the robo-v-mcu project that's led together with Plan B. We have today with us Mustafa, which can give us an update. Mustafa, stage is yours.
Can I share my screen? Yeah.
Please, go ahead. Sure.
No, not this one. Can you see? No. Sorry.
Yeah, we can see a presentation right now. That looks very well.
Yeah.
Awesome.
Okay, thank you. It's the first time I'm doing this presentation on this Ubuntu computer, so it was kind of problematic. So we have added the Ethernet MAC on the general structure with the UDMA part just right here. That's mostly the only modification we have done to the general system, except we had to create 125 megahertz RGMI clock. So we also modified this clock generator. Other than that, we did not modify any of the other projects so that it can go smoothly. So the inside of this of our module looks like this. We have this register interface and 2 cross-clock domain controllers for the forensics IPs interface, and then the buffers. These buffers and the controllers are also required to switch from this regular UDMA interface between regular UDMA interface and AXI stream interface. Controlling the module is pretty much the same with the other peripherals in the system, just like UART, SPI, I2C, that you have those peripherals already. We kept the same register structure actually. We just tied we just tied the connections and stuff and added some more status information. You can enable, disable the module, start the transmit, and set the transmit address, transmit size, and set the receiving address. In order to work smoothly, you can either poll the receiving status, or receive interrupt is much a better way. After getting the receive interrupt, you have to switch the receive address to not lose the next data. So as the conclusion, actually, on the RTL side, we are mostly completed. We are having it tested. For the software driver, we just began to work on it. We will be glad to receive a feedback on the RTL. I'm very sorry. Like, our hands are warm right now, so if we are required to add more functionality or do something differently, we'd be glad to know it immediately so that we can change it fast. And we need the clarification of the API requirements. And since we are starting to build a driver, it might be the right time to tighten the cooperation with Acceleration Robotics so that they can provide the necessary information about the API requirements. Then that's all. Thanks.
That's awesome. Thank you so much, Mustafa. Yeah. So maybe a couple of questions in here to follow up from this conclusion. Can you share with us the pointer to the RTL so that we can have a look and if appropriate, just provide feedback? That is kind of like a first one. And then I had another question regarding the testing that you're currently performing. Are you currently using any sort of Verilog test bench environment such as Coco TV or related?
We are using the test bench already given in the project.
In the Verilog.
We are just controlling the modules via software.
Yeah. Yeah. So if you're testing with the same tooling that's provided in the Verilog Ethernet repository, then you're using Coco TV definitely, and possibly also leveraging Icarus Verilog, which is the simulator that's used in there.
No, I'm sorry, we are not using the Coco TV. We are. I'm using the same environment with the Core 5 MCU.
Okay. So
it's already integrated. It can already be controlled via software. So I actually do like this: skip the booting stage, and just before the booting stage, I write my code and test it so that I don't have to wait the booting during the simulation.
Okay, got it. That makes sense, I guess. If you can provide in the minutes, I'll just put a placeholder in here, URL for the RTL. That would be fantastic in case it has changed or anything. And then, we from our side, at least from Acceleration Robotics side, we will definitely follow up and try to provide feedback as well as things so that we can meet in the middle. But yeah, fantastic progress, Mustafa. Very, very excited. And this is super cool. Very much looking forward. I think I did sync with you guys, especially with Max, on the hardware that you're using for the setup. So we should be in the same position. and having the same tools and the same things, I should be able to reproduce it pretty quickly. So yeah, looking forward for that. Thank you. So if you can drop that link in the minutes, I'd appreciate that. Otherwise, I'll chase you to try to get it there.
I don't know if I can just. I'm going to. We are going to reach you for this.
Okay. Okay. Sure. No problem. All right. So anything else to comment on the Robotics MCU project, folks? Any questions that we may have right now? Otherwise, we can jump into RobotPerf. None? All right. Mustafa, thanks a lot, man.
Yeah.
That was fantastic. All right, so maybe back into RobotPerf. That's the second topic of the agenda today. And again, I'm sharing the minutes. I know some of you guys just joined. So there you go with the minutes. Again, RobotPerf, we're looking at decent progress now that we are increasing the periodicity of these meetings, and RobotPerf is working or meeting weekly. So you can expect definitely more and more contributions, hopefully from many more. I wanted to touch on a few topics today. The first one is a hands-on session on essentially how to build and launch a first benchmark. I was planning to do it today. However, in the last week's meeting of the working group, we actually recorded it. So what I've done is just placed a link in the minutes that points to the recording of last week. So if anyone's interested in a deep diving source code wise on how you can build in a reproducible manner, as well as create your own new benchmarks, please refer to that particular pointer. That way we optimize time. Second topic that I wanted to touch on is the benchmark specification. So we requested feedback last month on the actual specification on how new benchmarks should be created. And again, this is hosted within the benchmarks repository of the benchmarks repo within the organization. I believe Matt, I don't know if Matthew joined us today. Jason, do you know if he's with us?
He's not with us, but I can speak on what we did.
Go for it.
So yeah, so there should be a pull request coming soon. But basically, we organized the definitions of what each part of our benchmark means, because a lot of the definitions and the words we're throwing out can get pretty complicated. So we took a stab at like, what is a benchmark? What is a benchmark suite? What is a workload? What's a reference implementation? So we clearly defined all of those things. And then soon when we, when we get that pull request in, if we can get the community feedback on that, that would be really awesome. Because all these definitions are not set in stone. We just started, we like placed a starting point that we can discuss and change the definitions around if we want to do so.
Awesome. So looking forward to get that pull request. And I know that Matthew reached out asking for privileges. I think I gave him what he needed. However, for sending a pull request, you don't need any privileges. So
yes.
So just feel free to shoot, and that'd be awesome. All right. So back into I guess sharing and going into some more topics that we will discuss today. So I wanted to touch on two more things, at least benchmarking wise. The first one is I wanted to report on some work that I did recently on creating a benchmark CLI tooling extension of the ROS2 CLI tools that I'll just show you just in a bit right now. And then I wanted to, so we have with us today also Michael Carroll from Intrinsic now. Hi, Michael. So Michael has been spearheading, I think, this fantastic initiative on ROS2 profiling. I'm actually pretty excited about it as well. So maybe we can touch on that, Michael, a bit and try to align on some of the aspects that I think we could benefit from each other. Just for the sake of being super brief, I did prepare an environment to show you guys this contribution this week on the ROS2 CLI tooling. I won't touch again too much on the structure of the benchmarks today. That's recorded and thrown last week, so you can go and check that out. what I'll show you is, and what we are doing right now is getting into dep containers. So we're using the same repo itself has dep containers prepared so that we can reproduce things systematically, regardless of which operating system you use. If you use VS Code, you can just open things up in the way that I just did. Technically speaking, what's happening is that you're actually entering and developing from the container. So the container, the Docker container, the virtualization itself is sharing volumes and is sharing links with the host system so that you can reproduce the same experience that you can have in your host system. That way we get a Linux kind of like a baseline set up with a series of things installed that allow us to allow concerns benchmarking. So what I wanted to show you is how, so let's just build the workspace that it gets out right away. So it's just gonna take a second. Merge install. So right now we're building it, and then we're going to see how we're gonna be able to visualize this new contribution this week, which includes a series of tools that we will be incrementally maturing and adding to manage and essentially play around with the benchmarks. So yeah, that's it. Now we can source this as an overlay workspace. And finally, we can see how to the typical tools that we get in the default ROS2 CLI installation. We now have a new one, benchmark one, which reads as various performance benchmarking related subcommands, right? And so if we ROS2 benchmark, now we have two subverbs or two verbs, one that allows us to list the benchmarks and one that allows us to the benchmarks. So the first one, ROS2 benchmark list, it actually recursively goes through each one of the ROS2 packages, searches for benchmarks. Each one of these benchmarks is defined by the corresponding, as you know, benchmark.yaml. So technically speaking, each benchmark is a ROS2 package. The only difference is that there is this extra file, benchmark.yaml file, which complies with the specification that Matthew and his team are reviewing right now. And this is a super simple YAML file, which just specifies a series of aspects that are useful for reproduction, launching, and then reporting aspects in mind. So hopefully this is something also we can touch on with Michael now in the discussion. So the tooling that we've created, the list verb or the update verb, help you navigate around benchmarks in that sense. So once we know which benchmarks are available right now built in this overlay workspace, we can pick, for example, the second one, ROS2 launch, and then we can just launch stuff. And that's gonna launch the computational graph. And then as we throw in input into the, data into the corresponding inputs, it's gonna start registering and tracing data that we can later on post-process with the corresponding analyze launch file. And that's as easy or as complex as it gets. So yeah, more verbs will start showing up in this CLI tooling. The update verb right now updates automatically the readmes of each benchmark as well as the top readme one. And this is going to get connected to a CI job within the GitHub repository that updates this every time we change anything. And over time, we'll be adding more and more functionality. For now, this is what I prototype and delivered. And there are a few next aspects that will come down the road, including prototyping this CI job that I just described. So with that, maybe we can spend some time discussing ROS2 profiling in alignment with this. Michael, I think that maybe you can say a few words about the effort you're leading and where you guys are heading.
You have a message there. You want to answer, respond to that first? There's a message in the chat.
Awesome.
I was just going to ask if there's a way you can add like a README inside that Docker folder to kind of help us get started.
Yeah.
How, like, develop with Docker and how like dev container.json like integrates with it, because I just don't have that much experience with it.
Yeah. Sorry. Yes, I can, Jason. And nevertheless, that's kind of like not something that I authored. Certainly not. It is something that's pretty standard in VS Code. It's so the best resource that you'll find out there is if you type dev containers VS Code and you read through the documentation. That's the best resource. But nevertheless, I'll take note of this and I'll see what I can do. Probably hard to make it better than the official documentation.
Okay, sure.
But yeah. Reach out to me otherwise.
Okay, thanks.
Cool. Yeah, so Victor, we kind of interacted a little bit on Discourse earlier this week. So this ROS2 profiling tool kind of grew out of the desire to be able to inspect, an entire running ROS graph and be able to derive a set of metrics or analytics from that, which I think probably has a lot of overlap with the same kind of metrics that you'd want to get out of a benchmark, and then be able to do analysis and eventually write kind of unit tests and assertions against the performance of a system. And so some of the kind of core tenets of what we were trying to do, one was kind of be minimally invasive. So not a substantial amount of recompilation or modifications to your existing ROS2 code base. So that's kind of how I arrived at the ROS2 tracing, which obviously in the rep 2012 or 2014, how many reps am I reviewing right now? You kind of arrived at the same conclusion, right? So ROS2 tracing is more or less universal at this point. Hopefully by the time that Iron comes around, we're going to have it enabled by default in the Debian packages. And it's using LTTNG, which is kind of an agreed upon standard way of doing tracing. So what this essentially does is builds a framework on top of that for doing the types of analysis that you would want from the ROS2 tracing data. And so the big things are being able to look at latency and jitter on topics. So if you have publishers and subscribers in your graph, you want to know like who's publishing, who's subscribing, how frequently are they sending at the time that they claim they should be. And then also being able to trace events all the way through a graph, which the ROS2 tracing, the trace tools analysis right now. So Christoph and some of his colleagues have done a whole bunch of work on being able to trace like message flow through the graph and use Eclipse's trace compass to be able to like analyze that. And basically I'm just kind of surfacing the same data, the same information in a way that you can make CI like tests against. So I think there's a lot of kind of overlap between maybe the analysis that I'm doing. Maybe you could just leverage that as part of the benchmarking tool. But yeah, really I'm trying to stay in using things that are available in ROS2 core, nothing super crazy or out there, and kind of surface the type of metrics that we'd be interested in.
Cool. Thank you for explaining all that. Yeah, we are, as you said, we are building up on the same baselines. We are both leveraging ROS2 tracing, which is the right thing in my humble opinion as well, though others disagree. Just to be clear for everyone, ROS2 tracing is not specifically tied to any particular tracer. You can use LTTNG or any others. So those of you Windows users, you can actually use other tracers. ROS2 tracing is prepared for that, actually, and it was validated in that context. And I love the fact that you're looking into graph tracing. The way it's being done right now for us in the group has been literally by not leveraging directly the information model that Christoph built initially as part of his ROS2 tracing effort. So he builds this information model, and then you can query that information model to try to extract the flow of the data. My understanding, and please correct me on this, Michael, but from what I've read, I feel that what you're planning to do is push that into the graph, right? Is that correct?
Push it into the graph in what sense? In
the sense that so Christoph has some sort of like representation of the timings that's stored locally, but kind of like in a particular memory section. I was under the impression that what you were going to do was kind of like push that data back into the computational graph, into the ROS2 graph, so that you can query it. But maybe I just got this from reading your comments. That was what.
Yeah, so not necessarily pushing it back into the ROS2 graph, but at least having an API that closely matches what you would expect from the ROS2 graph. So I guess I can actually share. I've got just like a little notebook here. So this is basically. I was not prepared to present, but I've got something. So this is basically using the recorded events that Christoph had set up. So there are all these various trace points. When the publishers and subscriptions are initialized, when publications and subscriptions actually happen, when timer callbacks happen. And so from that, I build this graph data structure from those events. So it basically gives you a different way of introspecting the events that have happened. So one way of looking at it is an event sequence through the graph. And so here you can see this is using the reference system from like the AutoWare reference system. So that's kind of got a bunch of publishers and subscriptions. And so what's happening here is we want to figure out why a certain callback is firing at a time. And that's kind of the endpoint. And what this lets us do is trace all the way back through the graph and see what sequence of events allowed us to arrive there. And it was from a timer at the 4 nodes back. So this kind of information would be really helpful especially if you have like long processing chains, like you would see in like an image pipeline, or if you have like complex data dependencies, it would let you sort of trace and see what the cycle time between maybe a perception input and a control output would be, because you get this chain of events for every time that callback fires, or every time a particular test point or a tracing point is reached. You could do this kind of analysis and say, this control output is attached to this perception input, and it should happen every 100 milliseconds. And what we found is that it's happening, not every 100 milliseconds or whatever.
And so just for me to confirm this, you're moving from Christoph's information model. You're creating your own graph-like structure. Is that correct?
Correct.
That's pretty awesome. Yeah, and that's going to be very useful down the road. So just to give you back maybe some feedback. So far, most of the analysis we've been doing on graphs have been reasonably simple and has been done manually directly from the trace files. So by leveraging BabelTrace Python API.
Right.
Which is very cumbersome, as you may know.
Yes.
Very, very cumbersome. But at the same time, it gives you a huge amount of granularity and data. So if you want to do fancy stuff, especially when related to hardware acceleration, which is what we're doing here, you often the case need that level of details, and especially because we are often the case not just tracing things at the CPU side of things, we are also mixing things up with tracers that run in accelerators. And often the case, each vendor has a specific tracers and profilers, and so we need to mix it all together at the CTF level, at the common tracing format level. So that's why most of the cases, even though it's kind of like very low level, I'm often the case just handling things at the CTF level with BabelTrace directly digesting LTTNG trace files. That said, as we evolve into tracing maybe more complex graphs, I think we will leverage much of what you're doing right now. So it sounds to me like we will connect quite nicely. Very exciting, man. Thank you so much for sharing this.
Yeah, happy to deduplicate and not reinvent the wheel wherever possible, right? And so this was primarily for the idea is that this could connect to a system under test without modifying the system under test, because that's a pretty big component of kind of these safety standards, is that the system as it goes in the field needs to be the system that you test. So in that way, this isn't modifying the system under test, and then it allows you to, make sure that the things that you say in your safety case are actually being met as part of the process. So I think it's very, very similar, to benchmarking, just a slightly different end goal, right? So I think there's a lot of overlap. I guess you could call it a benchmark, right? It's all about where exactly you want to draw lines.
Yeah, I mean, so definition-wise, there's some bits between profiling and benchmarking, but they are very, very close. I mean, we are using profiling and tracing to produce our benchmarks. So
Right.
technically speaking, benchmark has more that comparison side of things. But yeah, we're very close, and we will leverage everything. No, this is fantastic. So what I'll do is I'll be trying to follow up your progress, Michael, and maybe I'll ping you from time to time so that we can sync.
Yeah.
I would love to, not right now immediately because we're running out of time, but at some point I'd love to pick your brain on how to do data collection and then analysis so that we can maybe get the beginning and the end aligned, and that way we can build up on each other. Right now, again, we're doing things very raw in the sense that we are just grabbing the CTF trace data. And going with that, with just Babel Trace Python APIs. And again, we're not reinventing the wheel. We're just leveraging launch files, which just use Babel Trace Python API. But still, I do see the value of maybe leveraging that graph-like understanding you're getting in here.
Yeah. So the other part of this is it's actually kind of similar to your command line tooling as well. In that it's kind of a three-phase. So there's a launch, and basically you can give it an established launch file without modifying. There's a configure that tells which tracing things you want to enable, which instrumentation points you want to turn on, and those two things it will write to a particular place on disk. And then there is a convert that will kind of pre-process. Like you said, the CTF is kind of brutal to iterate through. It's much better to put it in an intermediate format. And there's some other discussion on ROS2 tracing about potentially picking a better intermediate format. And then there's a final stage, which basically lets you take a converted data log and run it against a Python unit test. And so this graph data structure is available in your unit test, and you can just write assertions like assert that this latency is under a certain amount, or this jitter is under a certain amount. I'm still working on some documentation for general public consumption, but there is some tooling in terms of running a system under test with the collection, doing the processing and doing the analysis as well.
Awesome. Once again, and this is fantastic. We're going to meet in the middle, having heard you. And again, we for the reasons that I explained, because we are dealing often the case with very low level interfaces and accelerators. We need to deal with things at the CTF level, but then I think down the road, as we start exploring more and more complex use cases, definitely we want to build upon your stuff. So we'll be paying close attention. Cool. Thanks a lot.
Thanks for having me.
Anytime. So yeah, we are pretty much, we reached the top of the half an hour, folks. I'm sorry. We dragged it a bit longer today, but it was definitely worth it. I just wanted to very quickly just give a heads up about two last bits that I think are worth you knowing. The first one is, and it was mentioned by Michael also, Rep 2014. So we in the past asked for feedback regarding Rep 2014. I will just do it once again. Please, guys, do comment, do provide feedback, try to contribute. We're very open to have new authors come join us in writing. I'm very contaminated. Every time I read it again, I get more contaminated. And I've spent so much time looking at it that right now I think I need some extra feedback. I wanted to say kudos for Raitha, who is doing a fantastic work reviewing. She's working on this branch. And so that the outlook of that is very, very positive. Just wanted to send word to those of you that want to contribute to maybe consider converting things into something that saves us all, myself, yourself, also as a reviewer and contributor sometimes. So one thing you can do, and I encounter often the case people that's not so familiar with these tools. So GitHub gives you a great tool to actually make suggestions. So if you are going through the text, not just demonstrated just right now, if you're going through the text and you encounter one bit that you think is worth modifying, let's just say this line, you can literally press in here and then make your suggestion in here. For example, let's just put an extra T in here, right? And so this is going to come out as a suggestion. And if you launch this, it's going to land into everyone. And so we can accept or reject or comment on the suggestion. I know this sounds silly, but given the complexity of this piece of text and the amount of people involved, this is actually the best way to move things forward. So I'll say just for anyone interested in getting familiar with this aspects of benchmarking and hardware acceleration, please go through the document and try to be constructive by sending comments in this manner. I spoke with Raisa about his approach. Hopefully, Raisa, you can send in some reviews this way, and that way we can get them in really fast. Okay, so besides that, and encouraging again everyone to just please send some additional feedback. Just last words from my side regarding the group growing. So as I reported, the group continues to have quite a bit of, let's say, attendance. We are 30 persons today. And again, we're increasing also the periodicity. So that made us reach out to the TSC to ask whether it made sense to make this an official working group, because it's right now possibly the most popular working group in terms of attendance and contributions. So the TSC reacted, at least Intrinsic folks, Catherine Scott, colleague of Michael, reacted very positively. They suggested to apply for the TSC, and that's what we did, what they suggested. We made a presentation for the TSC, and we're still pending on knowing the results. I guess Kat and everyone will inform us. Regardless of that result, we'll continue with our work, meetings, and so on and so forth. But anyhow, hoping good news on that side. Yeah, not much more to share from my side. Questions, comments, anything from you folks? I know we're 10 minutes over time, so possibly people want to get out and prepare dinner, in my case. Nothing else? All right, folks, so we'll close it in here. Thanks, everyone. Thanks, Mustafa. Thanks, Michael, for joining and reporting. Thanks also, Jason, and everyone from the team in Harvard for supporting with RobotPerf. We'll continue next week with a weekly meeting of RobotPerf, and next month with a review meeting of the progress of the working group. Thanks, everyone, and have a great one. Ciao, ciao.